Welcome to my channel. Myself Himanshu Yadav. Today I'm going to give introduction of object-oriented programming in programming languages. So basically, this is used for common word we use in the uh, programming languages. So this is the pillar of the we can say the development of the code. So here like we basically call the OOPS concept, or we can say object oriented programming. So nowadays whichever programming languages we are going to use, all these languages are going to use the concept of OOPS concept. So here, so what is OOPS? uh, Object oriented programming. Okay, so here like we first thing we have a data behavior. That means like OOPS combine the data properties and the methods that operate on that data with a single unit known as a class or object. Then we have a modularity here, so we can say OOPS promote modular design where each object is responsible for a specific set of tasks, making the code more organized and maintainable. And then with the help of the OOPS cons, we can do the code reusability. Like OOPS allow for the reuse of code through inheritance, composition, reducing development time and effort. So here, like here, this is the evolution of the OOPS. So this was evolved in 1960s. Then when we call Simula and Smalltalk was that time was the developer languages we basically used. In 1980s, the OOPS was going to be more like mainstream for the development. Like when they introduced plus plus, or we can say C. That time we are going to use the OOPS concept here. And in 1990s and 20s, like the different languages emerges in the market like Java, C Sharp, and much more in the other languages. So they basically based on this OOPS concept. So the main principle of the OOPS is like encapsulation, inheritance, and polymorphism. So encapsulation is nothing but this is called bundling data and methods within a single unit, class, or object to hide implementation details and promote data abstractions. That means we have to hide the logic, like whatever logic you are writing in the backend. Just we are going to display the result. Let's for example, let's say suppose you are going to develop a calculator. So in the calculator we can say when we are entering two numbers and we are clicking a plus sign, automatically it is displaying the result. In the backend, what is happening that does not need to be displayed to the user. So that is called the encapsulation. Inheritance, we can say by the name it is similar to like inherit, like something we are going to inherit from the superclass. Like we can say from the parental, we can say. So there is some habit, we can say some genetic will be transferred from the parent to the child. So similar kind of thing it is same, we can say the inheritance, like we have two classes. So from the class A we are inheriting some of the methods in class B. So there are some different ways to perform the inheritance in the languages. Polymorphism. So as the language as the word signifying that polymorphism, that means we will be having same name but with different functionality. So that is called polymorphism. Okay, let's go to next slide. So here the encapsulation, it is more in the detail, like how we can say what is it encapsulation. Like encapsulation is the idea of bundling data and its method that operates on the data with a single unit known as class or object. And the other thing is like how it works, like we have like hiding implementation. Encapsulation allows you to hide internal implementation detail of an object, exposing only the necessary information through the defined interface. So in that case, that means we have to hide the complex logic that we have written. Just we have to display the result on the UI. Data abstractions. By encapsulating data and behavior, you can create a higher level of abstraction, making the code more modular and maintainable. Example of encapsulation in the Python, we can say like here I have given some of the example here. We can go through it. The example how it works looks like. So inheritance is like it is a class hierarchy. Inheritance allows you to create a new classes based on existing ones, inheriting their properties and behavior. So it is like you can use the code reusable. By leveraging the inheritance, you can reuse the code from parent class, reducing development and time and effort. So we have like specialization, like we can say child class can specialize, or you can say extend the functionality of their parent classes, creating more flexible and scalable. So polymorphism. So here is a common interface, we can say, I just told you. So polymorphism allows object of the different of classes to be treated as object of a common superclass, sharing a common interface. Dynamic dispatch. The appropriate method implementation is determined at the runtime based on the actual type of object, enabling flexible and readable code. Okay, then we have a code flexibility. Polymorphism promotes code flexibility, as we can write method that can work with object of different classes as long as they are common interface. So here the benefit of this object oriented programming: we have modularity, we have reusable, we have scalability, we have abstractions. Thank you. Thank you for watching my video.